Is it going?
Yep.
Okay, so this is our final project for 233. We did image processing. As you can see here, this is an image being displayed on the Otter. We did that using this Python script here that takes in either a PNG or JPEG and converts it to an array that looks something like this. So pretty long, but you just copy and paste that into the assembly part of the program, and it will load it onto the board. And then we've got some functions to draw it to the screen and stuff like that, but you can look at the source code if you want to see how that works. So I'm just going to demonstrate it. This is the image process or the image display mode. The first of many modes is the grayscale mode. So flip the switches on the right to 1, and you press the interrupt button, and you get grayscale. The next mode is adding and subtracting color. So we can use the left 8 switches to do that. So let's add a bunch of red. You can add some more red. You can add just a little bit of red. Let's add some red and some blue. Make it purple. And then the next mode is subtracting color. So we can subtract all of the red, or we can subtract all the green, or we can subtract all the red and the blue and make it like a green scale, or we can subtract all the color and get no image. That one's very useful. The next mode is, I think this is average blur. Yeah, so this is average blur. Before, after. Now we're getting into the kernel convolutions. So I'm going to show you the code for this one. Basically, it's as easy as calling this convolve method with your kernel. So here's the kernel for average blur, kernel for sharpening, Gaussian blur, edge detection, and another sharpening kernel. They're just 2D lists, and you pass them in, and they'll do some cool stuff. So the next one, we've got sharpening. This sharpening doesn't look very good, but it is sharpening. And that's what it works. The reason that it takes longer to do the sharpening versus the average blur is because the matrix contains larger numbers. And since convolution is an operation that involves lots of multiplication, when you have higher matrix values, the lack of hardware multiplication makes it take longer to do. So moving on, this is Gaussian blur. I'm going to go back to average blur. Which one was that? And we can compare them. So here's average blur, and then here's Gaussian blur. So they're a little different. The kernels are different for that one, but moving on. This is edge detection in a way. It doesn't take into account like the direction of the edge, and it's done separately for each color channel. So the result isn't nearly as good as Sobel, but we'll see that in a little bit. So here's that running. You can see the areas without a lot of change. Like here, they get turned to black, but areas like this, those are going to show edges. What's our next one? Okay, we've got another sharpening filter. This one looks a bit better than the first one. So here's that. Just, you've seen sharpening on images before. That's how it's done. Finally, we've got Sobel edge detection. This is a bit more complicated than the other kernels. It isn't just one kernel that's applied to the image, it's 2, and then you take the magnitude of those if you treat them as a vector. So here's that working. So you can see the edges are highlighting. Added feature about this one is you can set a threshold for how sensitive you want it to be to edges. So this is with no threshold, so even the smallest edges are detected, but I found that this here is a good threshold for this. Oh, I lied. This is a good threshold for this image. We'll go one more. We'll go a little higher than that. Maybe even one more. Yeah, so this gets rid of all the small edges, and you're just left with some of the outlines. This image has a lot of noise, hence the remaining noise in the bottom. So what I'm going to do is I'm going to show you an image with less noise and do the Sobel again. I've already got the bit stream, so I'm just going to reprogram it real quick. So here's that new image. I won't go through all the filters again, but let's just look at Sobel. So this is with no threshold. Once again, I found that this is a good threshold for most images. And yeah, you're just left with the outlines. Pretty cool. Before and after. That's pretty much it. Those are like the common kernels. There's not really any other kernels that I could find that produce drastically different results. So we stopped here, but should be noted that you can load any image in using that script. So if you have the program, you can go ahead and test it out on anything that you want. That is all. Thank you guys for watching.